and here's an artist's conception of them dropping down. In fact, they were just designed to look at the atmosphere. They weren't designed to land on the surface and make surface measurements. But in fact, 2 of them actually did make it all the way down to the surface and land on the surface and go thump. And of those, 1 of them continued broadcasting after it reached the surface. So we have landed things successfully on the surface. But the real stars of Venus exploration has been the Russians, in fact, the Soviet Union, with a series of missions called Venera. And starting with Venera about 7, they managed to successfully get down to the mission, get down to the surface, and actually take some photographs. Here's the Venera 9 lander photograph of the surface of Venus. You can see this particular spot that they landed was covered with rubble. You can take these pictures from Venera. They were sort of crummy quality television, but since then we've had computer processing and some people have cleaned up the images and sort of cleaned them up, sharpened them, reprojected them to look flat. And this is a picture from the surface of Venus, halfway between an artist's conception and an actual photograph because it has been heavily cleaned up and modified. But this is what we see off in the distance of Venus. With around Venera 13 and 14, we started getting color images of Venus. And here's what Venus looks like in color. Again, you notice that very strong orange light, and that's simply because of the thick atmosphere. All of the blue light has been scattered out of the atmosphere, and there actually is sunlight at the surface of Venus. It's like a cloudy afternoon in Dayton, but it's a cloudy afternoon with sort of orangish, yellowish light. The Russians haven't been the only people going to Venus. NASA sent the Magellan orbiter to give orbital images of Venus because in the radar frequencies we can penetrate the clouds and see what the surface looks like. So here's a global radar map of Venus. You can also take that radar and project it and get the 3-dimensional images. You can even make these, if you had red-green glasses, you can make projections that would allow you to fly over Venus. And you can get a total map of the surface of Venus. This is, of course, false color, not true color. This has been colored with elevation corresponding to color. So the blue areas are the deepest areas, and the white areas are the highest areas above the surface of Venus. You can see actually Venus is a very odd and interesting planet with a lot of very bizarre features, including these extremely long sinuous rills that go for thousands of kilometers, very different from Earth. Final mission sort of worth talking about is we have also explored the atmosphere of Venus, and when I say we, I mean the planet Earth, namely the Russians, with the Vega missions that dropped 2 balloons into the atmosphere of Venus. Here's a photograph of one of the balloons. These are actually Teflon balloons. Teflon is quite resistant against sulfuric acid attack, and these were flying just a little bit above the thickest of the cloud layers where there's droplets of sulfuric acid. These were dropped into the atmosphere of Venus, and they flew for about 2 days in the atmosphere of Venus before the battery-powered mission ran out of battery power and simultaneously blew over to the sunlit side of the planet where they were out of view of the Earth. I've done quite a bit of study about surface exploration of Venus, and here's a couple of the artist conceptions from some of the proposed missions that I've worked on. But that's not what I'm going to talk about here. I'm going to talk about, the fact that surface exploration is difficult. The Venera probes lasted 2 hours. The Pioneer probe that made it to the surface lasted 1 hour. This is the longest time we've ever spent on the surface. It's a hostile environment, but a scientifically interesting environment. But let's talk about Venus. Can we send humans to Venus? It sounds difficult. It's the most hostile place in the solar system. You could call it not the twin of Earth, but you could call it the hell planet. As I said, high temperature, high pressure, sulfuric acid. On first look, you say that's a tough planet to go to. But take a little bit closer look. Like Earth, as you go higher in the atmosphere, it gets cooler. Here's a graph of the temperature in Kelvin, where, by the way, 300 Kelvin is about where humans like to live. So if you go up high enough, you go up to about 55 kilometers, and the temperature gets right about perfect. High enough in the atmosphere, Venus looks pretty good. Here's the atmospheric structure. So here's the altitude, temperature right above that sulfuric acid cloud deck. It looks pretty nice. It's this red murk at the bottom that's bad for humans. So if we want to send humans to Venus, what we have to do is we have to learn to live in the region up above the clouds. In fact, if you define sea level as the level at which the atmospheric density is equal to the density of Earth's sea level atmosphere, the problem with Venus is not that it's too hot on the surface. The problem is the surface is too far below sea level. Up at sea level, Venus is kind of nice. We could send humans to Venus. We could suspend them in that nice region of Venus, the sweet spot, 55 to maybe 75 kilometers above the surface. And humans, would have some problems. It's still a carbon dioxide atmosphere. You can't go outside and breathe the atmosphere, even ignoring the fact that if there's any clouds around, that sulfuric acid droplets. You can't breathe it. But you don't need a pressure suit. So everybody talks about space colonies. But space is a little bit short on all that stuff you need for life. Maybe we should think about Venus. Well, why Venus? Well, people talk about colonizing Mars, and they're serious. Any of you ever hear people talk about colonizing Mars? Yeah, probably you might have heard somebody mention it. Okay, well, Mars is cold. Mars gets to 100 below at the nighttime. You've got to live inside a pressure vessel because that pressure of about 1% Earth's pressure is not enough for you to live in. So the pressure vessels have to be mechanically robust. They have to hold a pressure of, remember, atmospheric pressure is about 10 tons per square meter. Atmospheric pressure is a lot of pressure. Temperature needs active control. There's not a whole lot of radiation shielding on Mars because the atmosphere is thin. And we don't even know if 1/3 gravity is enough for humans. We know that zero gravity has real problems for human health. You lose about 1% of your bone mass per month spent in zero gravity. You can do some countermeasures, but it's tough. But we don't know about 1/3 gravity. This is a complete unknown. And last is you can use that carbon dioxide as a resource. There's a lot of things you can do, but you have to compress it. Because right now it's at 1/100th of the Earth's atmospheric density. It's very tenuous carbon dioxide. So, well, people also propose space colonies. Any of you heard about space colonies? Does the name Gerard O'Neill mean anything to you guys? Yeah, a couple of people have heard of space colonies. Well, space is a vacuum. There's not a whole lot of stuff there. It has all of those problems of being that you have to live inside a pressure vessel, and maybe even worse. Humans do need gravity. You have to engineer gravity. That's an engineering challenge. There's no radiation shielding at all, and you have to bring all of your resources from somewhere. Gerard O'Neill said, well, bring it from the moon, but everything you need, even the land you live on, would have to be brought from somewhere. And all of those volatiles don't exist. They're hard to come by. You've got to bring them from somewhere. So again, space colonies, if you believe that that's a reasonable thing to do, you're putting it in a very hard place to put a space colony, where you don't have gravity, you don't have atmosphere, you don't have resources, you don't have radiation shielding. So Venus, on the other hand, in that sweet spot is superior to both of them. Superior to Mars, superior to the moon, superior to space colony locations. It does not have a vacuum. You don't have to live inside a pressure vessel. It's hard to sort of emphasize how heavy and robust, how every feature of your colony has to be driven by the fact that it has to hold pressure at an atmospheric pressure of something like 10 tons per square meter. The gravity is just about right. 10% lighter gravity, I can live with that. I don't know for sure whether the moon's 1/6 gravity is enough for humans, whether Mars's 1/3 gravity is enough for humans, but I will bet that 10% lighter gravity is okay for human beings. We do get radiation shielding. At the sweet spot in the Venus atmosphere, there's just as much radiation shielding as the Earth has, which corresponds again to that 10 tons per square meter of radiation shielding. That's a lot of radiation shielding. The volatiles are available right there. Lots of carbon dioxide, that's an easy one, but that's good stuff. We know how to make oxygen out of carbon dioxide. We can do it either technologically with zirconia reduction, or we can do it by the simple old-fashioned method using plants. Plants know how to turn carbon dioxide into oxygen. The rest of the volatiles used by humans are there too. Most notably, you do need water. You need hydrogen. There's plenty of oxygen there. But the sulfuric acid does contain water. It contains water at about 15%. But also it's easy enough to strip off the hydrogen out of sulfuric acid and convert that into oxygen. So there is the availability of water. There's availability of other things that are useful to human beings: nitrogen, sulfur, phosphorus, etc. So in many ways, I forgot to mention also the temperature is good at the sweet spot. In many ways, Venus is in fact the paradise planet. To colonize it, we need to float 50 to 60 kilometers above the surface, where the pressure is just about right. That'll put us just above those main thick clouds. So there's sunlight. We don't have to deal with the very orange, very low light. The temperature is reasonable. Depending at the bottom of that layer, you're about 50 degrees C. That's a little bit hot. You'd have to be cooled at that level. At the top of the sweet spot level, you're about 0 C. That's about right because humans do generate some internal heat. So probably 0 C is a good temperature because you will be self-heated by the fact that you live in a technological civilization with waste heat. Atmosphere contains the stuff that you need, lots of solar energy, and in many ways, Venus is actually the most Earth-like environment in the solar system. So if we're going to colonize space, and I think we should, one planet isn't enough. We need many planets. But perhaps the first planet we should colonize is not Mars. Perhaps that first planet is Venus. Here's that graph of pressure versus altitude. I had mentioned that right about at one Earth's atmosphere pressure comes at about 50 kilometers altitude. So you want to get maybe a little bit above this. Human beings are pretty good if you're in a mostly oxygen environment, down to about 0.3. So that region between 0.3 and 1 is about the region that you want to be in. Coincidentally, it is right in that sweet spot on temperature. Turns out it's not hard to float on Venus. That air is a lifting gas in a carbon dioxide atmosphere. Just ordinary air. If you took this room and you sort of chopped off this room and put light walls around it and floated it in the Venus atmosphere, we would float. The lifting capability of air in a carbon dioxide atmosphere is about half the lifting capability of helium on Earth. That's not bad. If you have a 400-meter radius envelope, you could float the Empire State Building, made out of concrete and steel, 350,000 tons, 1/3 of a million tons, with a 400-meter envelope balloon. And this means that floating in the Venus atmosphere, unlike floating in the Earth's atmosphere, where you float in a gondola under a balloon, in the Venus atmosphere you can be inside the balloon. So a Venus colony might look like this. This is my own personal sketch of a Venus colony. You can tell I'm a solar energy scientist because I actually put the solar arrays on. Of course, Venus colonies have been a fascination of science fiction writers as well. I just pulled this one out. This is a World in the Cloud showing a floating city, or at least a floating science station in Venus in 1980. I'm not sure how this floating science station is being held up. It seems to be a flying saucer, but at least they were talking about it. Here's another view of a floating city. This was a